Good day everyone. In the last video, we have discussed the important formulas from the concept of center of mass. Today we will be dealing with inertia and the theorems related to the moment of inertia. Let's get into the video. Please do write down all the important formulas because these are very important. If any question is asked from this chapter, you can directly substitute the formula. If you read all the formulas given in the videos of the chapter, you'll be easily able to solve any questions asking from the chapter. Okay, let's start. So the moment of inertia is given by summation of mi into ra square. Okay, mi into ra square. For the position, like already we have seen like mi into ra. So in case of moment of inertia, it will be ra square. Okay. Now, to find the radius of gyration, the formula, it will be denoted by k, and the formula for that will be root of r1 square up to rn square divided by n, which can also be written as, if you do use the derivation, you will get to know how this formula has been derived, which will be equal to root of I by capital M. This is for radius of gyration. Okay, depend upon the what values they have given, we can use the formula. And what are the factors that affect the radius of gyration will be position and direction on the axis of rotation. Okay, direction on the axis of rotation, and also the distribution of mass about the axis of rotation. These are the two factors that will be affecting the radius of gyration. Now, to talk about the theorems of moment of inertia, here theorem of perpendicular axis and also theorem of parallel axis. In theorem of perpendicular axis, it is nothing but Iz will be given by summation of Ix plus Iy. Okay, where Ix, Iy and Ix are nothing but the directional axis along the particular direction. Now, to talk about the theorem of parallel mass, it is given by I equal to Icm plus mx square. Okay, where Icm is moment of inertia about the parallel axis through the center of mass. Okay. So this is about the theorem of parallel axis. Now, for the moment of inertia for some regular shaped body, these are the common like shapes which will be asking in the question, and if you know the formula, we can directly use it and solve the question. So for rod, it is equal to ml square by 12. But when the inertia is asked for only one edge of the rod, you should be using ml square by 3. Like this, for ring, the moment of inertia about the center of mass will be m capital R square. Small or capital or everything is very important. Please make note of it. And if you talk about the diameter of the ring, it is mr square by 2. The same way I have given for disc and also for the solid sphere. Okay, this is about the moment of inertia for some regular shaped body. This is also an important one. And now we will see the formulas for torque and angular momentum and kinetic energy using the moment of inertia. Okay, so for torque, it can be written as I into alpha, and for angular momentum, we can write it as I omega. By deriving all the steps, you can also written it as rp sin theta. In this case, like it's not like only the final formula you have to use it. If you say in the given question they have given the values of m, v and r, you should use this formula. If it is I and omega, you should use, and if they given with the angle, you should use the final formula. Accordingly, you have to change, so you have to keep note of all the formulas. Okay, then to talk about the kinetic energy for the rolling one, it will be both combination of linear, which is half mv square, plus angular, which is 1 by 2 I omega square. And for kinetic energy of only rotation, it is 1 by 2 into I omega square. Okay. So we have talked about center of mass and what are the basic formula it is having, and now we have discussed about the moment of inertia. In the next video, we will be seeing about the difference between the linear motion or also the rotational motion. What are the formulas are there? So that will be really helpful for you to compare and read it. Yeah, we will see in the next video.